So by mistake what happened, that video is suddenly closed and I have to record a new video for this topic now. So now we are going to learn about this topic, ideal and non-ideal solutions. Okay, so what is ideal solution? Ideal solutions are those who follow Raoult law, or those who obey Raoult's law. So what is that Raoult's law? You remember that, right? That P1 equal P1 not X1. This is the Raoult's law. Okay, so the solution which obey Raoult's law are known as ideal solutions. Okay, and in case of in case of ideal solution, that the enthalpy change is 0 and the volume change is 0. And what it's mean actually, that enthalpy change is 0 means it is not exothermic or endothermic. Okay, that the enthalpy change is always 0, no heat is evolved in this reaction or no heat is absorbed in this reaction. And that volume change is also 0, like if the volume is volume of that solute and solvent is like 2 ml. Okay, then we get a solution, and that solution is also also have that volume is 2 ml. Okay, that volume is not changed. So in these cases, those type of solution are known as ideal solutions. So remember that for to being an ideal solution, it have two conditions, like del mix H is equal 0 or del mix V is equal 0. And sometime what important is that you have to write this definition, like if A interaction and BB interaction is equal to AB type interaction, then these things are known as ideal solution. Like A, what means by A? If we take that A is the solute and B is the solvent, then we know that in that solute they have some bonding between them, right? And these bondings are known as A. And in case of solvent also have some bonding between them, so this is known as BB. Okay, after adding solute in solvent, so what happened, that the molecule of A and B, they have a new interaction and it's known as AB. Okay, so if the interaction between A BB is equal to the interaction between AB, then these solutions are known as ideal solution. Remember that. Okay, so this is also a good definition for ideal solution. And you need to know about some example of ideal solution. So here they give like n-hexane and n-heptane. If you are going to mix n-hexane and n-heptane, then you are going to get a ideal solution. And then bromoethane and chloroethane mixture, and then benzene and toluene mixture. Okay, after that we are going to learn about non-ideal solution. Okay, so what is non-ideal solution? Those who doesn't obey Raoult's law are known as non-ideal solution. And now here, in case of non-ideal solution, we have two types of non-ideal solution. One is positive deviation, another one is negative deviation. Non-ideal solution means here they doesn't obey that Raoult's law. So here this is Raoult's law, right? So here this not equal to P1 is not equal to P1 not X1. Maybe P1 is greater than P1 X1, or maybe P1 is less than P1 not X1. Okay, so in case of positive deviation, P1 is greater than P1 not X1, and in case of negative deviation, P1 is less than P1 not X1. Okay, so we are going to learn about positive deviation first. Okay, so here we have seen that for this deviation lie in the nature of interaction at the molecular level. In case of positive deviation, what happened, that AB interaction are weaker than those A and BB. So AB is weaker in case of positive deviation. Okay, so if the bonding between A and B is weaker, then what happened, that since they are weaker, they are more volatile. Okay, so they can be easily fly away, and since they are easily fly away, they have a strong vapor pressure, right? They can be easily become to vapor, and because of that they have a strong vapor pressure. So in case of positive deviation, what happened, AB is weaker. So if it's weaker, since it's weaker, so it can be easily transferred to that vapor phase, and so it have more its vapor pressure is more than that vapor pressure, okay, which is get from Raoult's law. So here we have graph, and from that graph we can determine easily, okay. So this is for positive deviation. So this vapor pressure is for Raoult's law, okay. This vapor pressure is for Raoult's law. In case of positive deviation, since AB bond is weaker, so it can be easily become vapor, right? So we have more vapor pressure, okay. So in case of positive deviation, vapor pressure is increases like this, okay. Vapor pressure is increases. Vapor pressure is increases in case of positive deviation, like P1 is greater than P1 not X1, okay. And AB bond is weaker, remember that, okay. After that, in case of negative deviation, what happened? From that figure we can find out that maybe that vapor pressure will be decreased, right? Vapor pressure is decreased. That means maybe AB bond is stronger, right? Since AB bond strong, so because it's strong, so what happened? It cannot be transformed to vapor easily. So since it cannot transfer to vapor easily, so it have less vapor pressure. That's it, okay. Just remember that in case of negative deviation, AB bond is stronger, okay. So that's it. Here we have some example, like a mixture of ethanol and acetone. It's a example of positive deviation. What happened that if we are going to add ethanol in acetone, then what happened? Some of that hydrogen bonding could be break, okay. Some of hydrogen bonds should be break. So since hydrogen bond is break, so what happened? This bond become weak. The bond interaction between these two become weak. So before A interaction is stronger, BB interaction is also stronger, but after making mix them, the new bond should be weak, and since the new bond is weak, so that undergoes that positive deviation case, okay. And in case of negative deviation, we already see that AB bonds become stronger. So the mixture of phenol and aniline is the example of negative deviation. So what happened? A bond in phenol is weaker. BB bond in phenol is also weaker. But what happened if we are going to add phenol and aniline? Then there a intermolecular hydrogen bonding is formed, okay. So because of this intermolecular hydrogen bonding, this AB become more strong, and since AB is more strong, so it couldn't be fly away easily, so its vapor pressure will be decreased, so it's undergo negative deviation. Just watch this video more and more and more, then you can easily understand these things, okay. See that intermolecular hydrogen bonding, okay. So now we are going to learn about azeotropes. So what's azeotrope is? It's also easy. Azeotropes are binary mixers, okay, and they are binary mixer. That means they have two component in that mixer, and they have same composition in liquid and vapor phase. What's it mean? That we already learned about that if we are going to add two solution, to solvent and solute, then what happened? That in case of liquid phase, they have a mole fraction like x1, and in case of vapor phase, they have a mole fraction like y1. We already learned this thing in our previous video. So in case of azeotropes, what happened? Y1 is equal to x1, okay. So this is all about azeotrope, that azeotrope have that same composition in liquid and vapor phase, okay. So that means x1 equal y1. And azeotropes is also two type of: minimum boiling azeotrope and maximum boiling azeotrope, okay. And here we get some example, like ethanol water mixer is a example, okay. For example, ethanol water mixer, which containing 95% of volume by ethanol, and known as azeotrope composition, okay. And the liquid and vapor have the same composition and no further separation occur, okay. The solution that show large negative deviation from Raoult's law is that composition of nitric acid and water. Okay, so here we have seen that that composition which show negative deviation, last negative deviation is nitric acid and water, and that composition which show last positive deviation is ethanol and water. Okay, so that's it all for today's video. In our next video I am going to teach that in text question. Okay, so here maybe we miss important line, that the solution, this is important, the solution which show last positive deviation from Raoult's law, from they have minimum boiling azeotrope, and those which show last negative deviation from Raoult's law, they have maximum boiling azeotrope. Okay, maximum is last negative deviation and minimum is last positive deviation. That's it. Okay, so this is all about for today's video, and okay, study well.